So this one is scribe and etch handling. So the 3D, it did not recognize the text that's on the surface of the 3D
Yeah.
model.
Mm-hmm. Okay.
So
I'm
this one you
kind
would
of
be
guessing that might be
utilizing
the
the
case because I
2D.
think most of the scribes are added in the drawing level. But yeah.
Now, as far as the drawing goes, it is, if we could, this is very close to being extremely user friendly. With a little bit of process change, it could get better for you. But because kind of what we're looking at here is, you got your alignment. I'm not sure how well you can see with the colors on the screen share, but your alignment etches is, you see how it's coming in that purple color.
Mm-hmm.
So it automatically is going to etch those points. That, we're able to set that rule up very easily. If I kind of show you from scratch what we're doing, which I will in a moment. Now, the bend lines, if I select a bend line here, it shows my layers over here. It's on layer 0, color white, line type solid. That's
Mm-hmm.
the same as, okay, then we got this outer layer is cut. So there's a slight distinguished in that way. But then the text on here is on layer 0, which is the same as the bend line.
Okay, so that's marking it as a bend, or is it all marked as a scribe? Is that what that means in this case?
Yeah, so it's basically at this point it's not marked as anything yet. It's just that we don't want the bend lines and this text to do the same thing.
Right.
So it would be preferred that they would be on a different layer of some sort.
Okay.
And then the border is
Uh-huh.
on the same layer as the bend lines and the text.
Uh-huh.
And then these profile views here are all set on the cut. And we don't want those to cut because those are just reference views, basically.
Right.
So, kind of the way I approached this is I selected this text here and I changed it to a scribe layer
Okay.
for the text.
Mm-hmm.
The bend lines, we could either leave it the same or, what I did was I just selected the different bend lines like this and I moved them to a bend line layer.
Okay.
And then these, other views, I just deleted them.
Mm-hmm.
I don't have to delete all of it, just kind of delete some of this stuff here, and then I can use a clean, and that'll just extract out the geometry we're actually utilizing here,
Mm-hmm.
and then detect unfold diagram. Now, if you have those layers already kind of set up structured in a way that will, just leave you with this geometry when you're done, then we can basically set up rules one time, and then you can just bring the DXF files in or DWGs, and it'll automatically, sort all this out.
Mm-hmm.
Because what it does, if I add do a, just show you from scratch here. So I'm going to reference my bend line and add that in. And
Mm-hmm.
it's saying, okay, for all materials, all thicknesses, this is a bend line. I can even set up, specific angles. So you can have different angles on different layers or different colors or, anything like that. And we'll reference this scribe. So we'll add that one in. And that one will set as a marking line.
Mm-hmm.
And then the outer profile will get cut then.
Okay.
So then just make sure we've got that. I think that scribe. Okay. So what I did just to make it easier for importing is like the etching you had for alignment it's on the scribe layer, but the color is purple.
Mm-hmm.
So what I did is I just set my line style and line colors to to asterisk, which just means everything. Just look at the scribe layer. So then it doesn't matter what color or if it's a dotted line or a solid line. Anything that's on the layer scribe is going to be etched.
Okay. Okay.
So now whenever I move to the next screen, we get the red with the triangles. Those are indicating bends. So I'd be able to move this into my press break software and write a bending program from here. The purple is all going to be etched, and then the dark blue is going to be cut.
Okay, and that's a nice way to be able to check, I suppose, here too.
So yeah, we get a quick graphical, just kind of a confirmation there, and then we can quickly move this. And in this particular case, I know you'd probably do a nest or whatever, but we can move this into the blank cam and get a confirmation of that. And we can even save that as a part file. And then rather than bringing the DWG in, we'd bring the part file into the nesting engine and have all this assignment information ready.
Okay. How does that look there, Matt, compared to? Because this is very reminiscent of me, or very reminiscent of what I was witnessing them do with AutoCAD, where they take that SolidWorks drawing, have to correct a bunch of layers, move things around, delete things out.
This looks very similar to what they're doing. Yeah,
it's just in one piece of software
yeah.
and whatnot. Okay.
So this part isn't any of the nesting. This is just getting the parts ready, and that. Gotcha.
Yep, and it's working off of the drawing. Did you import the DWG/DXF, or is this from the SolidWorks file directly that you imported?
This was the DWG because I needed these purple lines, where you wanted that etching.
Okay, so that was still the export from SolidWorks. Okay, that's fine.
Yeah.
Oh.
Now
that other one, it just took that whole assembly. That came from SolidWorks and brought it.
Yep.
Yeah. Now, if there's if you wanted to use the 3D model and the very specific locations, like I'm assuming these are some type of alignment points for press brake bending or something, or welding.
Correct. It's I believe it's a mark so that the guy that's doing the press brake can connect those two lines and has a visual indicator where to align those bends.
Okay. Yeah. So like this exact length and exact placement has a pretty, has some tolerance to it then, where it's not like exact. So, I mean, if you wanted to, just kind of demoing this one step further, I think that number, that was what, 6068 was your number. If we, 606159, if we bring this part in here, I think is that the right part? Or it's at least comparable.
Yeah, they all have similar operation being performed. That was just a demo. Yeah.
So we can bring this one in through our 3D side. Move to the method. Just some bending stuff. Get a flat pattern here. So now we have our flat. And if we go into blank cam,
so this is bypassing the drawing and the DWG/DXF entirely and going straight to the 3D.
Yes.
I assume that you can import the
3D.
Yep. I assume similar to before, you can do the whole assembly file and then recognize each of the individual part files within that and parse them through into this workflow that you have here too.
Yes. Yep. The assembly processing, I processed it. That worked just like it did with the other one. No issues there. So here I'm kind of more demonstrating what this would look like, circumnavigating the use of the DWG file that you manipulate in AutoCAD, or, you saw the steps that I did in Production Designer to get it to work. If we just bring the 3D in, process, and we get to this point, I can select marking and I'll delete this out and I'll just type, 6068, and I can do different character sizes here and click, and then that'll automatically etch that text on there. Obviously you'd want that larger, that would place that on there. And then for my bend line references, You know, obviously you don't want to etch the whole bin line because that would take a lot of unnecessary time.
Yep.
But I can go into my laser assign, direct assignment, and E10, and I can just go in and arbitrarily, let me, I didn't hit complete,
Yeah.
but
Yeah.
you get the idea here.
Yeah.
Assignment there. So now that places, so I mean, these are just kind of arbitrarily being placed, but you know, it's accomplishing that goal.
Yeah. Yeah.
But I don't have to use
But all
anything
we would need is outer ones, right? Because we always go back to,
They have been marking both ends.
They have,
just
yeah.
because it gets so right to where that peak is, it gets so fine, it's hard to see. And
Especially
then
when
it
you start
starts
getting multiple
rolling. Yeah.
lines on there and everything. Mhm.
Now, once I do this on this part once, it'll remember it for the next time. But
If the exact same part.
the exact same part, it'll remember this every time. But if you bring in a different part, you know, something, then you have to do this for each part that you're doing it on.
Yeah.
Which is
But there's no 2D
Yeah.
file at this point.
Now, I
This
guess
is all-
another question. Yep, sorry, go ahead.
No, I was just saying this was all accomplished using the 3D file without having to reference the DWG.
Yeah, that seems a lot easier, but I know that shifts some of the burden of having to do some of the design work onto the guys prepping the laser, which I know would be a bit of potentially a problem there. Would there be a workflow that could be set up to detect those features like those bend lines and automatically assign some of those assignments, or apply the scribe mark automatically, say in the center of mass of that particular sheet, based off of the part name or something like that? Would that be something that can be set up so that most of this manual labor work can be automated?
Yeah, so it can automatically place this
Who does
text
this?
with the part name.
Mhm.
So that can be done automatically if that's what that is.
Yeah,
he's been doing it. I don't know where he's doing it, but you know, like the hopper stuff that comes in, but a lot of the stuff, you know, if it comes in blank, you know, me or Steve or Scott are doing that part.
Okay.
But I know Michael's
Uh,
about adding that in, but I don't know how much more labor intensive
so
this side compared to.
Mhm.
so I know it's cumbersome to add those scribe marks.
Yeah,
in
and that
SolidWorks.
I know Michael's told me that.
Mhm.
now I haven't played
Like
with
a lot more
this.
efficient way to do it.
Mhm. I think so. But
I'm gonna just I haven't ever actually played with this offset
Mhm.
1, offset 2 before. I just thought of this because you know it does do automatic bend line etching here.
Okay.
And we got offset lengths. So if we just back this out and then reload our parameters and actually just go one step further here. Let me jump back over here to part info.
Just
Marking,
automatic in the part number. Yeah.
So yeah, as you were kind of seeing there, the software is heavily preference based. So
Mhm.
We spend a considerable amount of time in the initial setup going through these rules and kind of setting it up to cover the 80-20 rule basically. And then we do any other manipulation once we're actually in the nesting engine itself. But
Okay.
yes.
It, it's etching most of it there, it looks like.
Yes, I'm just seeing what.
Which I don't know about you guys, but even if it did etch the whole thing, that might be more laser time, but that's less labor time. So, it's a kind of something the way, I suppose.
Like he can set up some rules there, huh?
Mm-hmm. Yeah.
Type 4. So, I might have to do a little bit more checking on how these offset lengths. Let's see, bin line dash. Okay, yeah, here it is, dash. Okay. L1 is the distance from the edge, and L2 is the length. So that's exactly what you want. Probably about 1 inch from the edge, 1 inch in size. So I just had that
Got it.
type set incorrectly.
Yeah.
And see there, put the part name up in the corner. I think we can adjust that to be in the center of the part if you.
Yeah. I was thinking like maybe your mass or something like
And the
that.
font.
Yeah.
Yeah, so you got your font there, and then you can set this to a fixed size or an auto search sort of thing.
Mm-hmm.
Let me move back this way.
Regenerate.
Yeah, so once we save, then we reload the parameters, and we re-enter into blank cam, and then it'll reapply those auto settings. So anytime you make a change in those parameters, you have to step back out of your nesting engine and then load the part in, because once you're inside of the blank cam, it's no longer looking at those automatic processes. That would be manual manipulation once you're inside of the program. If you want the auto to be adjusted, then you have to step out and then reassign the part data.
Yeah. Yeah, that makes sense to me.
Okay, so this one.
What kind of computers are you running this on?
What kind of computer specs do you have to run the software?
Okay, so my computer, I'm not a super big fan of it as far as they don't give me any sort of supercomputer by any means. This runs the software comfortably. My hard drive is about full, and I've noticed that's been starting to give me some issues.
Yeah.
I would not want to run it with anything less than this. The technical specifications only call out a minimum of, I think, maybe 8 gigabytes of RAM and an i5 processor. That will run the software. It's very painful.
Yeah. Our laptops are equal to or greater than that, so we're good.
Okay. Yeah, this is what I send. I send the minimum specs to people, but this is the recommended hardware spec sheet that I made. This is not an Amada letterhead document. This is my own document. If someone were to ask me, hey, what computer should I get to make this software run awesome? Okay, get this. It's going to be about $6,000, but it's going to run awesome.
Sure.
But yeah, so those are kind of your 3 stages. It's just like racing. I mean, how fast do you want to go is, how fast do you want to spend.
Mm-hmm.
But yeah, this looks like it, obviously you would probably want to manipulate, how these settings look, but I think this is kind of what you're looking for.
Yes.
Where it did the marking on either side of the bins just for 1 inch or however far you want to go. So
yeah,
based on so it looks like, based on what your needs are, now that I understand what those needs are more specifically, that's a part number and that those are bin line references, we can go straight from the 3D model to a laser program without using 2D or without doing any manual manipulation. So
now I guess another question is, can you set up different workflows for different kinds of product groups? So like in this case, we have a bin panel product group that makes a whole lot of these types of things. And we need them all to have those scribe marks. We need them all to have those part numbers on them. But then there's other product groups that don't necessarily have this number of things. We might not want to apply those same rules to, or have completely different rules. Can you sort of set up different profiles so that when you are in that work environment, that it knows to apply certain rules, or can you manually select different ones when opening up or an assembly or a part file?
Yeah, so there's kind of two ways you can handle it. So in here, I could have, so this is that rule that applied that bin line thing. So in my standard rules, I would have this set on none, so it's not doing anything. And then, and over here, I would copy that and I rename this, and I would say like bin shoot or whatever, round bin or something.
Sure.
However
So
you want to call that. And then this one would be set up.
Yeah, perfect. Yeah, so then regardless of whatever we're doing, as long as the person importing the job to get set up knows that this is a round bin system, they can apply that.
So this is one method of doing it. Before I nested the parts, I would open this parameter explorer up and go to my round bin parts and say set as default, and now it's going to respect this rule. And then when I'm done, I would go back and set it back to standard. So that's kind of the quick down and dirty way of handling it. Additionally, over in our cam condition settings, so this here is kind of our parent settings.
Yeah.
Now we can do subfolders here. So, materials, thicknesses, or laser material name. So that would be your cut condition name. So if it is a specific material type or thickness or cut condition that you're utilizing, I can say, okay, new thickness range of, 0.248 to 0.300 or something.
Sure.
And then I can set a rule up that follows that only if the part's within this thickness range, then it'll automatically apply it. If it's outside of that thickness range, then it's going to look at our parent settings.
Okay.
Or you can set it up for material type, thickness, or a cut condition name. So
it's stainless steel or was it aluminized, or if it's galvanized or something, you can apply different rules.
So also, Cody, in that entire assembly, there was a bunch of sheet metal parts, but there's also a bunch of angle iron.
And
so let's go ahead and I think we understand the etching side of it and those features. So let me go ahead and open up the assembly, and we can let's see here. That was round bin demo.
You select the different
Let's see here. I think this is the parent assembly. And it does, if you want to do configurations, you can adjust that. And obviously you see we're opening up SolidWorks files directly. The only comment I make on that or point I like to make is that while it'll import SolidWorks files, no problem, we're typically about 3 to 6 months behind on version. So like we'll get SolidWorks 2026 compatibility probably sometime around April.
Okay.
And the other side of it is that step files do import faster. So this took maybe 10 or 15 seconds to import. A step file maybe would have taken 3 or 5 seconds to import. So just a consideration, especially with very large assemblies, it'll still separate all the parts out and work exactly the same. It's just step files do open faster for really large or complex geometry.
Yeah.
So this is this the assembly that you were wanting to see that has some angle iron?
Yeah.
Okay. So we'll do the batch process. We can sort by thickness. So this looks like this part gets processed, I assume, this cut part. So that'd be 10 gauge. And then these are all these 1/4 inch parts are part of the main assembly. So you need all of those. So we'll process those. And then this looks like angle iron. All the 3/8 is angle iron.
Yeah.
Maybe not all of it.
Yeah, not all of it, but the ones you.
So these 4 components are angle iron.
Yeah.
So those ones we're not going to process. These components, it looks like we are going to process.
Correct.
3/8. And then this 1/2 inch ring, I assume you want that cut.
Yeah.
So now it's going to, you know, process the stuff we assign material to and not process the other parts.